Hey there, hope you're having a wonderful day. In this video, we're going to go over multi-level inheritance. So multi-level inheritance allows us to create a child class that inherits from a parent class, which can inherit from another parent class. For that reason, it is called multi-level inheritance. And multi-level inheritance is useful for building on top of various existing classes because the child class will then inherit attributes and methods from all the parent classes above it. So for instance, if I create a game character class and we create a warrior class that inherits game character, and then we create a knight class that inherits warrior, this knight class will inherit from both warrior and game character because warrior inherits from game character. So another way to think about it is you would inherit from your dad who inherits from his dad, so you would have qualities of your grandfather. So in the previous videos, we went over inheritance and the super function in Python. So here I have a game character class, and this is the base class or the parent class. So we have the constructor and we have health, which is 100, and we have a weapon. We can attack and we can recover. And we create a separate class, which is the warrior class. And this warrior class inherits from the game character. So this means that the warrior class can access these methods. And we also wrote an attack method for the warrior, so this would override this attack method from the game character. However, we can use the super function to call methods that we inherit from a parent class. So for instance, with a warrior class, we created this constructor and we used the super function to call the constructor of the game character. So what I can do is, if I were to create a warrior object, I can print is instance warrior and is instance warrior game character. This will check to see if our object is an instance of this class. So if I save and run the program, you can see we get true for both. So this warrior object is both a warrior and a game character because the warrior class inherits from the game character. And I can do print warrior.weapon, and I can also call warrior.attack. So if I save and run the program, you can see the warrior's weapon is sword, and we call this attack method over here from the warrior because we override it. So we're not calling the one from the game character. So we get slashed with a sword. Now let's create another class, knight, and instead of inheriting from the game character like we did with the warrior, we can consider a knight a more advanced version of a warrior. So what we can do is inherit warrior, and in doing so, we are also inheriting game character. So here I can create a knight object, and I can print is instance knight is instance knight warrior, and is instance knight game character. And I'm going to comment this out. So now if I save and run the program, you can see we get true for all of them. So a knight is a knight, and it's also a warrior and a game character. And I can do print knight.weapon and knight.attack. So we haven't defined anything in our knight class, so it's going to take from the immediate class that inherits, which is warrior. So it's going to call this attack method, and we're going to have a sword. So let's save and run the program, and you can see the weapon is a sword, and for the attack, we slashed with a sword. And if I comment this out and uncomment this, and I add is instance warrior knight, and I save and run the program, you can see we get false, true, and true. So a warrior is not a knight, but a warrior is a warrior, and a warrior is a game character. Alright, now let's comment this out and uncomment this one over here, and we can get rid of the type checking. So just like with the warrior, we can override the methods with knight. So I can override the constructor, and we still want to call the constructor for the game character because this includes health and weapon. So we're going to just copy and paste this over here. So when we create a knight object, it's going to call this, which then calls this, and then calls this constructor. And now that we have the constructor called for game character, we can also add additional attributes that only a knight would have. For instance, I can do self.weapon2 is equal to sword. So with a knight, maybe you have the ability to use 2 swords instead of 1. So here I can add knight.weapon2, and if I save and run the program, you can see we get an error. Warrior.init takes one positional argument, but two were given. And what is this one positional argument? That is self. So it's referring to the argument here. So you can see we only have self as an argument, but here we're passing in sword. So instead of doing it here, we would have to remove this. So we're calling super.init, which is warrior init over here, where we take no additional parameters. And then the warrior constructor calls super init with a sword parameter, which is then passed on to the game character. And this game character constructor does take that additional parameter. So now if I save and run the program, you can see the knight has two swords for weapon and weapon 2. And with two swords, you can attack twice. So I can override the attack method. And here I can just do print double slashed with two swords. So now if I save and run the program, you can see we have two swords and we attack by double slashing with two swords. And because the knight inherits from warrior, which inherits from game character, we can call this recover method. So here I can do knight.recover, and if I save and run the program, you can see the knight recovered 10 HP. And I can also add more attributes and method to warrior, which would then be inherited by the knight class. So over here, I can add another field, and let's call it raging, and I'll set it to false, and we can make the warrior rage. So here I'll do self.raging is true. And if a warrior is raging, the warrior will attack again. So if self.raging, I'm just going to copy this and I'll add again. And if I uncomment this and I do warrior.rage, and let's comment this out, let's save and run the program. And you can see the warrior has a sword and the warrior rages. So now we slash with a sword and then we slash with a sword again. And just to make it more obvious for us, I will print increased attack power with rage. So now if I save and run the program, you can see the warrior has a sword, the warrior rages, and then the warrior attacks twice. Now I can do the same thing with the knight. So I can comment this out and uncomment this. And before the knight attacks, we can make the knight rage. However, we need to do one more thing, and that is we need to add this logic, because when the knight inherits from the warrior, we only inherit this method and this attribute. We don't have this second part included because we override the attack definition. So here I'll do if self.raging, I'll copy this and I'll add again. Alright, now if I save and run the program, you can see the knight has two swords and the knight rages and then it attacks twice. Well, technically it attacks 4 times, right? Because we're doing double slash and then double slash again. And then we call recover. So with a multi-level inheritance, when we inherit from the warrior, the knight can use the rage method from the warrior and the recover method from the game character which the warrior inherits from. Alright, so that's the basics of multi-level inheritance. Hopefully you found this video helpful. And if you did, make sure you give this video a like. If you have any questions, let me know down below in the comments. And if you want to stay up to date for more Python tutorials like this one, make sure you subscribe to the channel, and I'll see you in the next video. Bye bye.